everyone. Today we'll discuss about the hydraulic turbines. Everybody knows that during the generation of the power, especially first of all, for generating the power, we need some mechanical force, mechanical movement. Except if you are using the photovoltaic cells, everywhere we want some mechanical force to rotate the rotor, the armature in the generator. Everybody knows that in the generator we'll be having a stator, a rotor, and that means in the rotor we are going to get the EMF is induced, and in the stator we will get the flux. We are going to generate the flux which is needed. In that flux, the armature or the rotor is going to rotate, and an EMF is induced in the armature conductors, and from there we are going to collect the electricity. So for generating the electricity, we mainly need flux and the movement of the conductors and the movement of the conductors. For that movement of the conductors, we need some external mechanical force. So this rotation, there should be a rotation. For this rotation, we may be using different methods. If we are using the thermal energy, ultimately we are using that thermal energy, and that energy is going to rotate the turbines, and this turbine is coupled with the shaft of the generator, and that armature is going to rotate and the power is going to be generated. And similarly, if you are using the wind energy, there also the wind, because of the motion of the wind, the fan is going to rotate, which is linked with the rotor, and again there is a motion, and again there is a production of the power. And similarly in the case of the tidal energy also. So because of whenever the wave comes, there is a mechanism such that the turbine is going to rotate. Whenever the tide moves inside and goes outside, the turbine is going to rotate, and during that period of rotation, we are going to generate the power. Similarly, in the hydropower plant also, so where we are constructing the dam, or sometimes we are not going to construct the dam, we are directly going to use the runoff rivers, small streams. So the movement of that water for the generating. Anyway, we are not going to get much power there, and they are not much reliable. So for more head, more force, and more reliability, we are constructing dams, different dams with different heads, and these headwater, depending on the height, depending on the head, the kinetic energy is going to be decided, and the force of that water is going to be decided, and based on that type of that movement of the water and the pressure, we are going to use the turbines. So these are hydraulic turbines. We are going to use in the hydropower plants. So these turbines can be classified in different platforms. So according to the type of energy at inlet, so we can differentiate these hydraulic turbines as the impulse turbine and reaction turbine. So the impulse turbine, it requires high head and low rate of flow. That means the flow rate should be low and the head should be high. So this type, we are for the turbine which is suitable for this type of conditions, we are calling it as a impulse turbine, and that is the Pelton wheel. That is the Pelton turbine. And the second thing which we can differentiate on the type of energy at the inlet is reaction turbine. So here we require low head and high rate of flow, so which is exactly opposite. So the Pelton wheel we are using for the high head and low rate of flow. The Francis and Kaplan turbines we are using in the areas of low head and high rate of flow. And again, that these turbines we can also differentiate in another method, that is according to the direction of the flow of the water through the runner. According to the direction of the flow of the water through the runner. So the tangential flow, radial flow and axial flow. So the tangential flow, radial flow and axial flow. So if the flow, it is tangential flow turbine, that is Pelton wheel, and for the radial flow, that is Francis turbine, and for the axial, that is Kaplan turbine. And if it is mixed, we can use the modern Francis turbine. And also according to head, if you are having high head, we can use the Pelton turbine. If you are having the low head, we can use the Kaplan. And if you are having the medium head, we can use the Francis turbine. And again, we can differentiate according to the speed of the turbines. For low speed, Pelton; for the medium, Francis; and for the high speed, Kaplan turbines. So if the speed is between 10 to 35, we can use the Pelton. Between 60 to 300, we can use the Francis turbine. And if it is above 300, we can use the Kaplan turbine. And also we can classify these hydraulic turbines based on the shaft, based on the position of the shaft. That is horizontal shaft, which is Pelton wheel, and vertical shafts, which are the Francis and Kaplan turbines. So the Pelton wheel, you can see it will be having a nozzle, it will be having a hand wheel, it will be having a stopper, it will be having a casing, it will be having a spear, it will be having a tail stalk, it will be having a pitch circle, it will be having a runner, it will be having the buckets, and it will be having the braking jet. So this is about the so this is the horizontal shaft turbine, and remaining the Kaplan and Francis are the vertical shaft turbines. And this is about the hydraulic turbines. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.